All right, guys, so this is section 5.2, mean of a random variable. So last section we were talking how to create a probability distribution. So this time we're going to talk about how to find the mean of the probability distribution, or in other words, the expected mean, which we'll talk about what it means by expected mean in a little bit. All right, so basically, this sums up what I'm about to do, right? So we want to find the expected mean or the mean of probability. So most of this stuff is pretty much done in gambling, and I'm going to give you guys a little example of how it's done in the real life, like your insurance companies and stuff like that. But it's mostly done in gambling. For instance, you put money in, you want to see, what you expect out on every single roll. That's what we're going to be dealing with here. So you can pretty much do calculation-wise, are you getting money or losing money based on every single roll, and especially the lottery, right? Since we talked about the lottery in section 4.4. This goes really big when it comes to, buying in and buying out kind of stuff. So again, later on I'll give you guys a little interesting example as well. And then question 2 will also be pretty interesting. All right, so just a quick little portion, right? So this is a probability distribution, right? X is a random variable, represents the sum of dots. So just a couple dots together when it comes to it. So we have, 2 dots covered by 6 by 6. So obviously total of 12, right? 1 and 1 gives you 2. So 2 through 12. And this is the probability of the sum being those portions there. So define the expected value of the mean. It's actually one of the easiest equations we're going to be dealing with in stats. It's pretty straightforward. There's no dividing, there's no square rooting. It's just straight out multiplying and adding. That's it. So the expected value is looking like this. So you multiply literally x times expected p of x, and then you add them all up. And that's it. It's pretty straightforward when it comes to this kind of stuff. So essentially, we're literally going to be multiplying straight down. So x times its expected probability, so you literally multiply straight down, and then add them up. That's the expected value. So that's what you expect to happen on an average roll itself, so every single portion. So I'll give you guys a quick, couple minutes. This is a pretty straightforward equation. Go ahead and try question 1. All right, so find the expected value of the probability distribution of rolling a pair of dice here. So using this portion here. So go ahead and pause it. 3, 2, 1, go for it, and we'll do it together. All right, so now let's do this together. So you multiply straight down. 2 times 0.028 is 0.056. 3 times 0.056, 0.168. 4 times 0.083, 0.332, and we keep going, right? So we'll go a little faster since hopefully you guys did it all. Oops. 1169. Right? And then once we have them all, we just add them all together, right? And that's going to be our expected value. So essentially just add everything together, and we should get so hopefully you guys got 7.007. Okay. So what does this actually mean? So what this basically means is the average, right? So what this is saying is for every roll, so for every roll of the 2 dice, we expect the sum to be 7. Okay, so essentially, right, for every roll you do, on average, it's going to be 7. So we expect a 7 on every single time when it comes to it, or the average is going to be 7 itself. Okay, that's how we're going to do this kind of stuff. So it's pretty straightforward calculation, but the interpretation is what, it's most important when it comes to things like that. So we get a little example, the real life scenario you guys may be more interested about. So question 2 says, the probability distribution gives the potential cost of routine maintenance and major repairs in the first 5 years when you own the car. So pretty interesting, right? If you guys own a brand new car, look for it. How much is it going to cost to repair, annually? And obviously, right, the first year shouldn't be zero because it's a brand new car. But wear and tear. Eventually, you want to figure out how much you're actually spending in the 5 years. So here's your probability distribution. So over the cost of 5 years, so $0 and so forth. And this is the probability actually having that kind of cost in the 5-year span. Okay. So the question is, find the expected cost of routine maintenance and major repairs in the first 5 years when you own your new car. So essentially, right, you want to find the expected value. So notice it says it didn't expect the mean, but it gave you the expected cost. So that's what you're looking for. Expected means the same thing as the mean of the situation. So in other words, we'll do the same equation we did up here. Okay? So when it comes to that, we're really going to, again, multiply straight down because these are the x variables, and this is the probabilities, P of x. Right? So we just multiply straight down, add them all up, and that's what you expect to actually the expected cost you would have maintaining the car for the first 5 years if it's brand new. So let's just do this quickly. So 0 times that's 0, right? 500 times 0.65 is 335. 1,000 times 0.09 is 90. 1,500 times 0.04, 60. And then finally, 2,000 times 0.01 is 20. All right, so now we just, add them all up and see what we expect to happen. So 0 plus 335 plus 90 plus 60 plus 20 gives you a grand total of $505. Okay. So again, if you want to do this when it comes to interpretation, which is, again, most important when it comes to stats, is we would expect to spend $505 on routine maintenance in the first 5 years of a new car, which should be too much, right? Well, it depends, right? Oil changes, things like that add up. Tires and stuff like that. Tires don't last forever, things like that. So depends on that, but not too bad, right? Everything wants to be low when it comes to it. So that's pretty much it. That's 5.2. That's it. That's the end of the section. It's a very short section, like I told you guys in class. When it comes to it, that's it. So I'm going to give you guys one more example. Since it's pretty short, it's only a minute video so far, and it looks like this. So what if it's a major thing? So everybody's known about life insurance plans, so things like that. Why if you want to why can they give you so much money if you unfortunately pass away, right? They'll give you like $100,000, $200,000 life insurance if you pass away. How can they afford to give those kind of plans when you're not only ask for like $100 a month or something like that? Well, here's a scenario for you guys, so I'll read it out loud. So suppose an insurance plan states that it will pay out $100,000 in the case a person dies. In order to have this plan, a person must pay $1,800 a year. Okay, that's roughly around $120 a month. Researchers have found the probability a person living through the year is 0.9996. Find the expected amount you would get if getting this plan. So much you pay off or lose based off this plan. Now this is a very interesting question. Okay, so it's a little different scenario than just straight out the ones I gave you before. The first thing we have to do is actually construct the probability distribution. So going back a section. Okay, so in this situation we have two things happening. Either you live or you die, right? It's one or the other. So a person lives, a person dies. So essentially, the X represents, the money, the payout you actually get, and the probability, so P of X is, the probability of you actually getting the money. Okay. Now here's the thing. Again, there's a little catch based off this scenario here. All right. So X is the the money cash itself, right? Now, when it comes to it, if you unfortunately pass away, according to the scenario, right, how much you will actually be getting out? So hopefully everybody said 100,000, right? But here is the problem. Okay. You actually don't get $100,000 because technically you already had to pay $1,800. And hopefully this nicely, there we go, perfect. So like I said, you had to pay actually $1,800. So essentially what you're actually getting out after you pay that $1,800 is 900, what is it? Let me just write this down. $98,020 or $200. That's essentially what you're getting out based off the scenario. Okay, so when it comes to this probability distribution, so these X variables is the money, so you'll get $99,200 if you unfortunately pass away, right? Now the other one is, well, you also paid $1,800, right? When it comes to it, well, remember, you're gaining this amount, but since you're paying, you're actually losing if you actually live throughout the year, right? Kind of funky how that works, but if you live through a year, you actually lost $1,800. But if you pass away, you gain this amount of money. So that's why this is a negative, because you're losing money essentially when it comes to it. Now the next thing is the probability of X. So the probability. Now in this portion, they said the researcher found that the probability of you actually living is this amount, right? 0.9996. So when it comes to living, well, that means if you live, that means you're losing money. So this probability goes right here. Now again, right, going back a section, well, the sum of all the probabilities must equal what? Hopefully you guys said 1, right? So I gave you guys a scenario last time, right, where, solving for one of the whole variables, you have to solve for it, add them all up and then subtract by 1. So in this case, the probability of you actually winning or gaining this money is very, very low. It is 0.0004. Okay. So that's how we do this problem. So the whole thing is you first have to set up this probability based on that scenario. So again, right, this is quick for a little illustration how you actually have to do this. Again, we haven't finished the answer question yet, but it's the setup. It's a pretty interesting part. So this is what the insurance companies do as they go about doing their business. Okay, how much this and that. But we're going to see how would you actually gain money or lose money based off this scenario? So let's try it out. So we want to find the expected number, so we want to find the expected value. Okay, so you straight out multiply, when it comes to it. So it's 98,200 times 0.0004. So this gives you $39.28. Multiply this out. And don't forget to keep the negative. Gives you minus 1799.28. Okay. Well, remember, right? Once it comes to this, we want to take the sum. So we're going to add these together. So negative 1799.28 plus 39.28. So adding these together gives you negative 1760. Now, what does that actually mean? Okay. Well, let's think about this. Going back to this portion, right? This is saying on average what you get to this portion. So in here, on average, you'll be losing money because it's in the negatives, right? So remember, plus is positive, negative is negative. So essentially, on average, every year, you'll be losing $1,760, every year of your life. So essentially, so if you want to, how these companies can do that is exactly that. They just find the probability of you, living throughout a year. Well, they do research about that, and they can just, take the money based off that. So notice every year you have this insurance company, you're actually losing money. So there will come a point where you will be actually getting more money than $100,000 you actually give out. So, it's kind of a trap when it comes to it. People have, insurance plans based off that and all that fun stuff. It's kind of good, almost pass away, but, essentially, like everything else, it could be a trap and, an excuse to actually make money off of you. So, essentially, this person, or a person, right, depending on what it is, will lose $1,760 every year as long as they're alive, which is pretty crazy, huh? So, fun little example illustrating, some insurance companies, things like that. And again, you could do this for everything, life insurance, health insurance, fire insurance. That's the reason why they do this. So, the probability, they find the probability of, an actual happening, worst case scenario, things like that. It's never going to happen, right? So, this is pretty much you're almost 100% chance of living throughout the year. Super, super small, when not surviving. So, things like that happen all the year, on a daily basis. Okay. All right, so that's it for this section. It's a quick little section, like I said. It's only one video, so it's section 5.2, mean of a random variable or the expected number itself. Now, one thing before we go, when it comes to this is, I forgot really quickly, when it comes to the mean, this is also called E. So the expected stands for E. So expected value is capital E as well. So they either say mu or E is also expected value. It's abbreviation for them. Okay, so just be worried when it comes to that. It's mostly when it comes to the x expected is E for this probability distribution. But again, rarely on occasion they say find the mean portion, because again it's the same thing. All right, that's it for this section.